Hey kids, happy Saturday, and we're so glad to have shared the last semester of Access with you guys. It's been a rough semester online, but we hope that you've taken away something from these videos and have an increased interest in electrical engineering and you just learned something. Whether you don't decide to pursue it at all or you decide to study it in college, we hope that you have a good understanding of just like the basics and are at least a little bit interested in what they do. This video will be a little bit more in depth of kind of the theoretical concepts of electrical engineering, like what you might actually see in a classroom, and some of the applications and even some of the real circuitry that we've been working with for the past few weeks. So hope you enjoy, and we'll see you next semester.
Hi guys, welcome to another week in Access Engineering lessons. So the goal this week for this lab is that we're going to design a simple circuit using a push button. If you haven't seen a push button before, this lab will be a good introduction to it. And you can see it illustrated here. You've got your Arduino, LED pin, resistor, and your push button. So we'll get into it. So for this lab, the parts that are needed are going to be Arduino, your cables, breadboard, red LED, jumper wires, a push button, and your resistors. So the way that the push button works is basically it's a device that has two sets of pins that are always connected, and then when you press the button, all of the four pins become connected. So if you see this illustration on the right here, the lines to the left and the right, when you push the button, this little lever kind of thing connects both sets, so then you can have your current running through. So it really is a nice device that, when you don't press it, it can stop the flow of electrons through the device, and when you do press it, it does connect all of them. We will also be using a DMM to measure things like voltage and current. Today we'll just focus on voltage, and that is the potential difference between 2 points. If you think of it as being like 30 feet high, like your potential that you're driving the voltage from, in real life, every voltage measurement has a reference. So in this case, it's like ground or 0 volts. So when you bring it up, like 30 feet to ground, or is relative to ground, and that's kind of like how to think of like your DMM. It takes 1 point relative to the other. And to test, we connect the black negative to ground and the red positive to what we want to test. And so for this first part, we're going to be turning the LED on using hardware. You guys can always refer back to this example, and looking at the previous slide, if you look at what's connected, that you can gain like a better intuition of what is going on through the circuit. So starting from the 5-volt wire, this is connected to the push button through the bottom right terminal, and then the bottom left terminal of the button is connected only to the resistor. And maybe stop this video and see if you can trace the rest, like see which way the current goes through the circuit. Nothing is actually connected but the top 2 rails here, if you look. So it is time for the lab in person. You can recreate the simulation in person, and all connections should be identical to what you just did in Tinkercad, and no code is necessary because we're using the built-in hardware functions of the Arduino for this one. Be careful not to connect ground to 5 volts directly because this could damage your board, and always use a resistor with an LED to avoid damaging the LED. So this is a nice little illustration we've got on the left. It's a little bit more like structured looking, and then you see in real life, it's the same exact thing. It's just, wires aren't straight. They're a little bit curved and everything, but if you follow both pictures, you'll get the idea, and hopefully your circuit works as expected.
Hi everyone, my name is Miles and welcome to part 2 of this week's lab. Okay, so first we're going to talk about turning on the LED using code. So as you can see in the diagram to the right, the push button is no longer connected to the LED directly. Instead, it is connected to the 5-volt directly. So when we push the push button, the voltage at the column where the green wire is connected to will be 5 volts when referenced against ground. The LED is connected to pin 13. You can see that here. And that will send a high signal whenever the Arduino detects that the push button is pressed down. Okay, and here's kind of a built image of what this diagram would look like. Again, you can see that it goes to 13. And again, the Arduino will know that when the button is pushed down, there will be a high message sent to 13. Okay, so now we're going to look at the code. And this probably looks really intimidating, but we can figure it out. Okay, so first thing we'll look at is, or we'll question, how can we read whether the value sent to a pin is high or low? Because remember that high message was sent to that pin in the last diagram. Okay, so the digital read function takes in a pin and it reads whether the value sent to the pin is high or low. And here int val, we create an integer called value, and that stores the value. And we read that to pin 7. Down here, this green area, we use an if statement that turns the LED on using digital write if val is double equals to high when the push button is pressed. So if the high message is sent, essentially, we run these functions. Otherwise, we run digital write LED low. Okay, now we're going to talk about logic gates. So we've discussed how to use a button as a single on-off switch, but how would you create more complicated systems? How would you, for example, make a circuit where you have to press the 2 buttons in order for the LED to turn on? Or how would you make a circuit where you can press one of the 2 buttons in order for the LED to turn on? Okay, and to answer that, for the first question, you connect them in a series, one after the other. For the second question, you connect them in parallel beside each other. So this is a series circuit. So we have an AND gate here. So we connect the 2 buttons in series. You can see here, these are in series, one after the other, and that will create an AND gate. The first button and the second button must be pressed at the same time in order to light up the LED. And then we have an OR gate. So this is still using a parallel circuit. We connect the 2 buttons in parallel, again, one beside each other, and that will create an OR gate. The first button or the second button can be pressed in order to light up the LED. And that compares to the last slide where they had to both be pressed to light up the LED. You, baby, baby. Oh my God, I'm still recording.
Hi everyone, welcome back to Access. I'm Aditya, I'm one of the electrical engineering teachers. Welcome to the last session of electrical engineering at Access. I hope you guys enjoyed these videos. And today we're going to talk about chargers, conductors, insulators, voltages, and current. You guys have probably experienced a little bit about these things before, but we're going to go a little bit more in depth today, and we'll be using Khan Academy. So if you don't already know about Khan Academy, it's a great resource that you can definitely utilize for high school. They have math, physics, chemistry, everything. So today we're going to use their physics lecture, and this is one of the articles they have. So we're going to talk about current, voltage, power, but also charges, conductors, and insulators. So we're going to read it, and then we can, I'll talk about it a little bit more. So as it says, voltage, current, power. So what is a charge? This concept of electricity, the concept of electricity arises from an observation of nature. We observe a force between objects, that is, like gravity, acts at a distance. The source of this force has been given the name charge. A very noticeable thing about electric force is that it's large, far greater than the force of gravity. Unlike gravity, however, there are two types of electric charge. Opposite types of charge attract, and like charges repel. Gravity has only one type, it attracts, never repels. So real quick, let's just look at a magnet, for example. When you have magnet against so this is metal, I'm not gonna write magnet, but like this is magnet. If you bring magnets close to a metal, you feel a force that like pushes them together, and that's the force. And this force is that's the force of electricity. That's the electric force. And the reason we see this is because of charges. And when charges of the same type, so for example, the two types of charges that they said, that is negative and positive. So when they say opposite charges attract, they mean when you have positive, negative next to each other, they'll attract. And when you have negative, negative next to each other, so they attract. Those are small arrows, and these will repel. Or even if you have like positive, positive. And this you've probably seen in magnets. So if I had a north-south magnet here, and I have a north-south magnet here, you're going to see that these will repel each other, and you won't be able to like touch them. This will want to go this way. This will want to go this way. However, if you have N and S next to each other, there's S here and N here, these will attract each other and they will eventually stick. Cool. So that's about charge. Charges are what cause these positive particles. They're obviously very small, but there'll be a bunch of, so there'll be a bunch of like positive signs here, or these positive particles, and there'll be a bunch of positive particles here. So what we know from this situation is that they repel, and that's why this entire system repels. And in this case, we have a bunch of positives here at the edge, and then we have a bunch of negatives here. And these attract, as we know from here, and that's why this entire system attracts. Cool. So now that we know about charges, we can talk about conductors and insulators. So conductors are made of atoms whose outer or valence valence electrons have relatively weak bonds to their nuclei, as shown in the image below. When a bunch of metal atoms are together, they gladly share their outer electrons with each other, creating a swarm of electrons, not associated with any particular atom. A very small electric force can make the electron swarm move. Copper, gold, silver, aluminum are good conductors, so is seawater. So by this, they just mean, for example, we have our metal here, and this is basically a copper element. And if we have a bunch of these, this extra electron is just here. So there's just a bunch of extra electrons here, and these atoms are like all here. And because atoms are bigger, they don't move, but these smaller electrons, they can move around. So when you have all these free charges, so an electron is a charge. So if you ever see how an electron is written, it's written like this. I mean, this is basically equal to a negative charge. So if you have a bunch of charges, free charges moving around, they can very easily like move together. And that's basically what electricity is, moving charge, or what current is. And we're going to be doing that next. So that's basically a conductor, a few types of as they gave us the example, these few things are good conductors. So they conduct charges really well. These charges can move really easily. On the other hand, insulators are the complete opposite. It's really hard for charges to move, and they don't have this kind of structure where there's like this free electron that can just roam wherever it wants. So insulators are not like that. They have a rigid structure, and that's why we're going to notice that insulators such as glass, what's an example there? Glass, plastic, stone, air, they're all insulators because they don't have these free charges that can move around and conduct electricity. Semiconductor might be something you guys haven't heard before, but it's basically something that acts like an insulator sometimes and then acts like as a conductor sometimes. And at really low temperatures, semiconductors become like, you don't really need to know about this, but semiconductors at really low temperatures work as conductors, and at room temperature they're usually insulators or a little bit of both. It depends really on the type of element that we're looking at. But yeah, that's all about the types of things around us. So if you look at anything around you, it'll either be a conductor or a insulator or a semiconductor. So I have a ceramic glass that's an insulator. Then I have my phone, which has transistors in them, which are semiconductors. Then I have metal around me, conductors. So they're just things around you. Talking about current is basically the flow of charge. So once again, let's imagine this is a metal strip, and we have a bunch of atoms in them, and then each of them have this extra electron out there. When you apply a force, so just like how gravity you'd apply a force, when you apply a force on this metal, you're going to notice that all these charges move with that force. So if you've applied a force this way, and that, for example, you put a magnet here, so there are all these plus charges here, all these negative charges, they feel the force of this, so they're all attracted this way, and they all have a motion this way. So the motion of charge, or the movement of charge, is what gives rise to current. You guys feel free to read this article later. I can just go through the gist of this thing so the video doesn't get too long. So this is basically what they've shown you here. So you have a metal here, and the movement of charges is designated by this. Another thing about movement, why you see that the current is in this direction, is because we don't know why, but whoever came up with current, they decided to say that the current is the direction of positive charge. It's the direction of motion of positive charge. So because we have electrons here moving in this direction, the current is in the opposite direction, because electrons are, as I said, were negative particles. So when negative particles move this way, we say the current is this way. And when positive particles move this way, we say the current is this way. So current is basically the movement of charge in the movement of positive charge. And you don't really need to worry about this notation. This is a bit of calculus here. And this d by d dt, this just means that motion. It's just talking about the change of q over time. And the change of q over time, so the motion of t over time is basically r. Cool. So yes, current can be carried by positive charge. We saw how electron moves. We also know how positive charges move. As you said, what causes current is just the motion, the movement of charges. So it's the motion of other charges. The speed of charge, the speed of current, sorry, it depends on the force you applied. As we talked about when we had the little thing, the greater this force is, the faster these particles move. And the faster you move, you obviously have more current. Cool. The next thing is voltage. Again, again, this is something that you guys have probably experienced, but voltage just tells us to get our initial, let's read through it, to get our initial toehold on the computer. Voltage, let's look at this analogy. Voltage resembles gravity. And looking at this graph, we can see if we have something on top and it is a certain distance away, there's gravity acting on this entire system. This entire system has gravity acting on it. We see this ball roll down. Same thing is with voltage. So voltage is just potential difference, which basically says that at this point, this particle has some kind of potential to move. There's a potential to move. And whenever there's a potential, you can have motion. There was a potential difference. So this was at a higher potential and this was at a lower potential. So when it goes from high to low potential, it basically it does that motion through movement, and that movement is what we detect as current. So this potential is basically your potential difference or voltage. So voltage has a couple of names, and potential difference is one of them. Cool. Again, this formula you don't really need to know. Next, we can talk about power. Power is just, to keep it very simple, power is the voltage you calculated above times the current. That's very simply the formula that you need to know in any kind of classes you take. P equals V times I, and that's also what they've shown here. So they've said power is defined as the rate energy is transformed or transformed over time. We measure power in units of joules per second, also known as watts. That's just a unit. So for example, current has a unit of amps, ampere. Voltage has a unit of volts, and power has a unit of watts. Cool. To summarize, today we talked about current, voltages, and power. If you want to obviously read more about this topic, Khan Academy is a great resource. If you want to email any of us, we'd be happy to help. I hope you guys enjoyed these access sessions. I know it was online. There were a couple of issues with that, but of course, as I said before, you can reach out to any of us if you have any questions, and hope you have a great rest of your semester. Bye, everyone.
Hey guys, so today I'll be talking to you about the video you'll be watching this week, which revolves around an electrical engineer at Valero Power. So Valero Power is just a large power company present in the US. So you'll learn a little bit about them as well as some of the daily work of an electrical engineer. The work of pretty much any engineer is, very fast-paced and flexible. So you're going to work on a variety of different projects while at many different companies. But specifically for the electrical engineering route, you're going to learn quite a lot about the typical work that they do, especially at a power refinery. So you're going to learn a lot about that. And also you'll learn about some of the tasks that an electrical engineer does on a daily basis. So that includes a lot of project engineering, as well as some maintenance work on some of the power systems that Valero has in place. So it'll be really interesting for you guys to take a look at some of the work that they do and maybe think about that this could be something that you'd want to study in college or in the future. So definitely give it a look. If you guys have any questions, obviously we'll go through it this week during Access, but enjoy.
Hey everyone, now we're going to give a quick recap of what we learned this semester. We first studied why we study electrical engineering, and we saw that electronics were a big component of the everyday devices that we use. As for the design process in electrical engineering, we saw that we first start off with a schematic, then design a layout, and ultimately design the product. We then discussed Ohm's law, and we saw that Ohm's law was a very fundamental law that electrical engineers use to design their circuits. We also looked into designing our first circuit, which was essentially an LED and a push button, and being able to turn on the LED whenever we turned on the push button. We also introduced a component called an Arduino, where we can upload code onto the Arduino to be able to control parts of our circuits. We then also started talking about the code that's put onto the Arduino. And the code in Arduino is written in C. And essentially we use different variables to be able to control the different components in our circuit.
Hey guys, again, thanks so much for watching. All our videos will be available on our YouTube channel for you guys to view at any time. So if you forget something, want to learn more, just feel free to go back and look for all subjects, not just this one. So thanks for watching your video, and we hope to see you back next semester. Bye guys, have a good Thanksgiving and holiday break.